page 60 is where we're on, and what we're going to be doing is learn how to do a hypothesis test with two proportions. Because the reality is that a hypothesis test with two proportions is more common, much more common than a hypothesis test for one proportion. And here's why. You would typically, if you do all the experiments that get done, well, you have data from one group, and then you're not going to compare it to, say, like somebody says it's 7%. No, you'll have, say, one drug and then the other drug, and then you'll compare those two proportions and see what proportion of them still had high blood pressure or whatever. So it is much more common in experiment, because of experimentation, to compare two proportions. So therefore, this is really important topic for us. Now, there is a different standard deviation that you must use. It is on the back of the formula chart. So here's the back of the formula chart, and we have the one sample standard deviations for the mean and proportion. So we know these ones. We know these well. But down here, if you have two samples, then we have to combine them correctly. And this comes from the idea of how, how standard deviations cannot add. See, it comes from that, and you had to go through the Pythagorean theorem of statistics. That's what this comes from. Here we have the square root of the one standard deviation plus the other one, that one squared plus that one squared. Anyway, so this is the formulas for two proportions standard deviations. But we actually won't do that very much. I'm not going to really have you do the computing of the two proportions standard hypothesis test and find the standard deviation by hand. I'm going to teach you how to do that in your calculator today. All right, so let's go ahead and move on. Now, the good thing about these two proportions is I will let you calculate in your calculator. The bad thing is we have to do conditions for both proportions or both groups. But I'm going to try and simplify it as much as possible. So it's kind of like two random independent large enoughs. But we're going to do one, and under each thing address both items. One thing that we have to add, this is like basically a new condition, and it will go under independent, is that the groups are independent of each other. For example, if I was comparing, the proportion of girls that think that proportion of women that think men are intelligent, and the proportion of men that think men are intelligent. If I had those two separate groups, okay, then I have to also account for the fact that those two groups have nobody in common, and a person's vote is not being double counted in the groups. Of course, this being a gender kind of naturally falls, but it's the same thing. Have to make sure that the groups are independent of each other. The two groups have to be independent of each other. So that's the added topic or condition that we have to put in. Now, you have this on your next page. Okay, so this is a notes of how to fill out a phantoms model, and that's what we're going to learn how to today. So you've got this on your next page already filled out for you. So first off, when you define your parameters, you have to define both of them. So you have a P1 or a P2, or you could make it more meaningful subscript like P of M for proportion of men, and then P of W for proportion of women. Okay, so you're welcome to use a meaningful subscript like that, but make sure you define those for all of their populations, their respective populations. All right, now for the hypotheses statements, the null is that those two groups have equal success rates, because we start off saying everything's the same until you prove otherwise. Give me sufficient evidence to say that the other item is less than, greater than, or not equal to. Okay? So that will be how the alternative hypothesis statement will look. Now, here's an example of what the conditions will be like. We would first say random, and again, these are randomly selected for both groups or randomly assigned to the treatment groups. Now, guess what? Be forewarned. Most things that we've done so far have been randomly selected, but these are going to be more experiments and getting data and experimental things. So if they are experiments, then what wording are we using for those? That we randomly assigned to the treatment groups. So be forewarned that that's going to crop up more here than it has in the past. Okay, randomly or assigned to the treatment groups. So you can claim a cause and effect. Okay, independent, show that both of them are less than 10%. So the sample of the first is less than 10% of all of the population of the first group. Second one is less than 10% of all of the population of the second group. And here's our new improved condition that we have to add under independent. It's reasonable that the two groups are independent of each other. Nobody counted in both groups. All right. So that's the only added condition. And finally, for our large enough, we've got its proportions, so it's the NP and N times 1 minus P are greater than or equal to 10. You do it for group 1 and group 2. And finally, normal model applies. Okay, so not much different there. This is a 2 proportion Z test. So instead of a 1 proportion interval or a 1 proportion Z test, it's now 2 proportion Z test. And then the next part is where when you use your calculator, you can then just write down the Z score and the p-value. So that is allowed to just write down your Z score and your p-value. Let's see here. Then we get our p-value, same. Now the rest of this is similar to what we have done. You compare it to alpha and you reject or fail to reject. Since the p-value is less than or greater than alpha, I reject or fail to reject the null hypothesis. And there is sufficient evidence that there is a difference or there is not a difference between this and that. Okay, so there's the outline. Let's now do one. Okay, so turn to the next page, and we're not going to do this top part, but I'm going to read it because it kind of guides us into what this question's about. So this question is wondering if being part of a support group that meets regularly helps people who are wearing a nicotine patch actually quit smoking. So a county health department tries an experiment using several hundred volunteers who are planning to use the patch to help them quit smoking. So we're not going to go into the design of the study right now. Let's go ahead and read this suggested study. Here we go. These subjects were randomly divided into 2 groups. People in group 1 were given the patch and attended a weekly discussion meeting with counselors and others trying to quit. People in group 2 also used the patch, but they did not participate in the counseling groups. So after 6 months, there's the results, and they list a number for a proportion for group 1 and a proportion for group 2. Do these results suggest that the support groups could be an effective way to help people stop smoking? So we want to know if it's more effective. Is there significant difference? Is it significantly better? That kind of thing. That is a test. So we would then run a phantoms model. So we're going to do that on the next page, and you're going to it's blank on the next page, and you're going to do that. So turn it and let's do this. All right. So for our parameters, we have 2 groups. Okay, group 1 was doing what? Okay, group 1 did patch and counseling. And so what's the proportion that we're measuring? What's the denominator going to be? Denominator would be the smokers who are wearing the patch and go to counseling groups. So that's the denominator. And then what's the numerator? The ones that quit. Correct. Good. So this is the proportion of all such smokers who use nicotine patch and get counseling. That's your denominator. Proportion of all such smokers who use the nicotine patch and get counseling that successfully quit smoking. There's our numerator. Okay. And then our second group, what was the qualities of those subjects? Patch only. Good. So the denominator is the proportion of all such smokers who use patch only, nicotine patch only. So the proportion of all such smokers who use the nicotine patch only that successfully quit smoking. Okay? All right. So we got our people. They were probably volunteers. So that's where all such smokers comes in. People of this, that were this motivated, that are like these volunteers. Okay. All right. So the null hypothesis is what? Yeah, that the success rate is the same for both groups. Until you prove to me that one's better than the other, I'm just going to say they're the same success rate. So the null hypothesis is that P1 equals P2. The alternative, what are we wondering? Good. Is the addition of the counseling give a higher success rate than the patch alone? Now, over there on the side, I wrote down numbers just so that I don't have to flip back and forth to the other page. So I went ahead and wrote those down. P1 was 46 over 143, and P hat 2, the sample results. So that's kind of the sample results. All right, let's see. Now what? Our favorite part. Our assumptions and conditions. So here we go. So what is the random one going to be? Aha, this is an experiment. Very good. So it was stated for both groups that they were randomly assigned to the treatment groups. It was stated for both groups that they are randomly assigned. That part I wrote in blue was the part that killed people 2 summers ago on a free response. They lost a half a point, which is a big deal, maybe more, because it depends, anyway, the way the rounding goes sometimes, okay? All right, so it's randomly assigned to the treatment group. Okay, so that's good for both. Got them covered. Independent. So that's one independent. What do we do? N is less than 10% of the population. So here are my ones. So the first group was 143, which is less than 10% of all smokers with patch and counseling. That's the population for group 1, smokers with patch and counseling. And then the second group had 151, is less than 10% of all smokers with patch only. Okay, because of the proportion concept. That's a good question. And I was actually going to mention this a while ago. Do you think, say you started with 300 volunteers, by the end of the study or the end of the experiment, you're down to only 143 people that still met the qualifications. It could be that some of them started taking another pill or I don't know, or moved or whatever. You end up losing some of your initial starting people, and then you only have so many. But when you put them in terms of a proportion, that makes them out of 100, so then that equalizes it. Okay, but in this independent, we have an addition to put here for 2 proportions. What is it? I am saying it's reasonable that the group participants are independent of each other. Okay, so the people that in the nicotine patch group, or the patch and counseling, are different from the people in the patch only group. Nobody double counted. No, I just keep it in the independent so we can still get real. It would be, we could get Ryle. Put also. Okay. All right, here comes now our large enough. So our large enough is the successes and failures. So look here. So I have group 1 is this little section. Then I have group 2 is this little section. So I have successes. This is who successfully quit, and this is who failed to quit smoking. And those are both greater than or equal to 10. Now, look at this. This is interesting. I'm essentially using the sample data. Because was I told a population P, like what I expected for each group? No. And that's going to be common. You pretty much won't be given a true P for these problems. You will just be given sample data of one group and sample data of the other group. So I'm really dealing with my sample results. The successes of group 2 is greater than or equal to 10, and the failures of group 2 is greater than or equal to 10, and finish it up, normal model applies. All right. Now, so far has there really been much different than what we've done before? No. In my mind, other than doing two things, there's that one little condition added, pretty much the same. So here, name of our formula or test. What's the name of our test? Good, a 2 proportion Z test. And now here comes the magic. We're going to do this in our calculator. So get your calculator out or go get one and go stat over to tests. Stat over to tests. Okay. So I have listed here on the left, over here, the full menu of all of the tests that we are going to do this year. Look at all of these tests that we're going to do this year, with the exception of 2 of them. This one down here, that's a 2-sample F test, and a NOVA. Those are both like the next thing that you would do after this course. So out of all these things, we'll eventually do them all. Now, these, if they do not have the word proportion in the menu item, it's about something else other than what we're doing right now. For example, these top 4 items that say just a Z test, T test, 2-sample Z test, 2-sample T test, that's about means. Look at number 5, by the way. Number 5 is a 1 proportion Z test. So, guess what? Could have been doing that in the calculator, but I made you do it by hand. Which, it's very, there's meaning behind doing it by hand. You need to know that process, so I have you do it by hand with the 1 proportions, but once the computation gets tricky, you're going to use the calculator for our 2 proportion Z test, okay? Also, then there's more means, and then chi-squared and linear regression. Okay, so we'll eventually do all of those, but today we're focusing on number 6, 2 proportion Z test. All right, so now, over here on the right, I have what we're going to put into our menu. So, the first 2 items are for your first group. X1 is the successes. That has to be a whole number item. That's not a decimal. That is not a percent. If you get errors, it's because you put a percent in there and not the number of items. So in this case, there were 46 out of the 143 in group 1 that successfully quit smoking. Okay, now X2 and N2 are your data for group 2. X2 is the successes in group 2, which is 30 out of 151. Okay, so those are your two sets of data. No proportions or no decimals in there. Now, this next line represents what you are doing for your alternative. So was our alternative P1 is not equal to P2, P1 is less than P2, or P1 is greater than P2? We were wondering if it's greater than, if the success rate is greater than P2. So highlight this last item in that row. And then go ahead and do your calculating. Go on down and calculate. When you do that, you get this menu here. And look at that first thing. Guess what that is? That's your z-score, 2.41. And then the next item, the p, that is your p-value. That's that full p-value. Okay? Now, these other things down here, let's just go ahead and talk about them real quick so you know what they are. P hat 1, what do you think that is? Yeah, that's the results of group 1. P hat 2, that was the decimal value for the second group. Okay? Now, I haven't calculated this in a while, but I think this right here is the pooled P. I think this is like the total of the two groups over the total denominator of the two groups. The total numerator over the total denominator. That'd be cool if somebody figured that out for me real quick. See if that actually was. To do that, you would be doing like 46 plus 30 over 143 plus 151. Okay? And I think that that's what this p hat is here. Any potential, it is? Somebody did that? Perfect. Okay, that's what I thought it was. What do you see as an issue here that we've talked about in the past that we kind of need to be mindful of? What has happened when we've combined things like that in the past? Dun, dun, dun. Simpson's paradox. Yeah. Okay. So and so there's something with like how this is used and when you can use it and all those kinds of things. All right, because that is an issue there. All right, but we'll go on. So that's why you don't use these other items here. Okay, pretty much not doing those other things. So back to this. Let's finish this guy out. So we've got our z equals, so all I have to write there is z equals and p-value equals. All nice and neat, just had to write that. Should get something easy since our conditions were so time-consuming. Okay, so look at that p-value. What would happen with that? We're going to compare it to alpha. And so I'm going to compare it to my 0.05, and so that p-value is low. Reject HO. Okay? Since that p-value is low, reject HO. Okay, so here comes my conclusion. Since 0.008 is less than 0.05, I reject that. I'm going to go ahead and put, I've been seeing that I think it'd be easier to write just the P1 equals P2 right here, and then in the next sentence put the context in. So let's just write what HO is here. P1 equals, I'm rejecting that P1 equals P2. Okay? And then in the next sentence, I'm going to put context in there. So if I am rejecting that P1 equals P2, then what do I have evidence of? Okay, but I'm going to do this in context, so then I have evidence that, the proportion of smokers that quit with patch and counseling is greater than the proportion of smokers that quit with patch alone. And so that is then the context. Okay, so that's the phantoms. That's all I wanted to show you today. I want to show you the panic model tomorrow. And so your assignment, let's go over here to page 65 real quick and have a little discussion about your assignment. I want you to do just the phantoms. So I want you to do problem number 1, part 1, problem number 2, part 1. Okay, there are 2 problems here. One of them is about Jennie-O and store brand chicken and the proportion of them that are contaminated. And I want want you to do the phantoms model for that one, not the panic model. Okay, and then down here, this one is about the proportion of women who think men are intelligent and the proportion of men who think men are intelligent. Do the part 1, which is the phantoms, not the panic yet. But I want to have a little discussion of a very, very common mistake before I let you go free. By the way, I also do want you to do page 76 alone. That's one review page. Okay? 76. So 2 phantoms and page 76. So let's have this little discussion here. Problem number 1. There's the information we get is this. 33% of the 75 packages in Genio are contaminated, and 45% of the 75 packages in the store brand are contaminated. The issue is, when I am going into my calculator and I'm putting in stuff for X1 and N1, this has to be a whole number and not a fraction. It cannot be 0.33. You cannot put a decimal in there. So how do I put, what is my number of successes if it is 33% of 75? Okay, right. So what that is, you have to then go, 33% of 75 is 24.75. But, oh my gosh, can you have a decimal 24.75 packages of chicken? No. So round appropriately. So that's why I called that 25 packages of Genio chicken. Okay. So that's my warning to you based on what they give you. It will give you an error in the calculator. And if it does, then that's your problem. You got your decimals in there instead. Okay. So that's the only other little trick I wanted you to catch before you do your assignment. So I'm going to walk around.